Life on Earth. Impossible as we know it without radiation from the sun and gases in the atmosphere. The so-called greenhouse gases in the atmosphere help maintain an even temperature on Earth, making the planet inhabitable. But these gases are a double-edged sword. Today, there is a growing concern that increased concentration of greenhouse gases in the atmosphere may cause global warming, with irreversible environmental changes as the possible outcome. At present, about 80% of the world's energy consumption comes from fossil fuels. When fossil fuels are burned, carbon reacts with oxygen and becomes the greenhouse gas carbon dioxide. Increased fossil fuel use is thus followed by an increase in man-made CO2 emissions. Something that goes under the name of CCS technology represents one of the solutions to our environmental challenges. Emission scenarios, although still under some debate, indicate that future CO2 emissions must be reduced by 50 to 85% within the next 50 years if global warming is to be confined to between 2 and 2.4 degrees Celsius above pre-industrial levels. With the continued high level of CO2 emissions, our children could inherit a planet with unwanted and considerably different living conditions. Improving energy efficiency and deploying renewable energy are important measures to reach future emission targets, but not enough. In order to meet future growth in energy demand, a consequence of population growth and increased living standards, the world will still need fossil fuels for decades. But emissions must then be reduced. One of the most promising technologies, enabling up to 90% reduction of CO2 from large stationary sources, is CO2 capture and storage, or CCS. CCS implemented on the main CO2 emitters have the potential of contributing to 20% of the low-cost greenhouse gas emissions reductions needed to avoid the average temperature on Earth rising more than 2 to 2.4 degrees. Simply put, CCS is a collective term for different technologies employed to capture CO2 from large fossil-fueled power plants and industries, and to transport and store this captured CO2 in underground geological formations. The analogy to production of natural gas and oil is striking. The chain is simply turned around. CCS involves separating the CO2 from fossil-fueled power plants and industries, compressing and transporting the purified CO2 back into suitable geological formations. Large-scale deployment of CCS on fossil-fueled industry has a ways to go. Today, the costs of integrating CCS on industry sources exceed the benefits. Technological development can reduce this gap. The Norwegian research center BIGCCS reflects the need of improving CCS technology. BIGCCS include partners from global industry and R&D, working on technological development in order to reduce costs and improve the efficiency of CCS solutions for big stationary CO2 emitters. Researchers at BIGCCS work within all technologies from initial CO2 capture to transportation and final storage. Today, the dominating share of CCS costs relate to the capture process. BIGCCS work to develop and enhance capture technologies for different applications. The center looks at how to optimize CO2 pipeline design and to enable safe and cost-effective design and operations. In addition, BIGCCS develop methods to qualify safe and persistent geological formations for long-term underground storage of CO2, while monitoring methods are developed to ensure successful injection and desired long-term behavior of the storage site. In total, BIGCCS seek to find the optimal components in different CCS chains, either by capturing CO2 emission from an offshore oil platform or an onshore coal or gas-fired power plant. CCS will induce a cost to society, the cost of enabling low-emission use of fossil fuels. The world as we know it will continue to be strongly dependent on fossil fuels in decades to come. With expenses in mind, estimates show a 70% increase in costs if we are to reach emission targets without making use of CCS. the cost of doing nothing may be what future generations will be forced to pay for centuries. The timing of CCS is critical. The International Energy Agency, IEA, considers the next decade to be a make-or-break period for CCS. Action must be taken before it's too late. BIGCCS represent industry and knowledge institutions with a great potential of developing energy solutions for the future.